Okay, this is question number 9 in your optimization packet, and I'm going to take a quick look at the question and then move the screen over so I have enough room to work here. It looks like we're trying to maximize the area of the window. So I'm going to have area equation first as my primary equation, and then I'm seeing total outside perimeter of 60 feet. So just keep those in mind as we work through this problem. So like I said, I need enough room to work here. So we're going to start with an area equation, and my area is going to be devised of two parts here. So the first part is and it doesn't matter in what order, but I'm going to start with the rectangle. Seems like a pretty good place to start. So if I'm talking area of this rectangle, I'm going to say that I've got some base times height. And again, that's area of the rectangle, plus then I've got this semicircle, and I've got that area. So plus area of the semicircle is pi times radius squared divided by 2, or 1/2 times pi times radius squared. So here's my area of the circle, although it's really a semicircle, and then area of my rectangle. So that gives me area of my total region. And of course I'm adding them together. So I want to, I believe, maximize the area. Just going to do a quick check. Maximize the area of the window, yes. Okay, so right now I actually have 4 variables. I'm okay with 2, one on the left and one on the right. So we're going to keep this A here, and I'm going to try to get rid of 2 of those 3 variables. Not going to be totally fun. So I'm going to say let's keep my R in terms of radius, because I can't do much with that with my circle. But let's take a closer look at our rectangle. And if I take a look at my rectangle, I'd say that right here I actually have, let's grab another color. This would be my radius, which means that the other side is also a radius. So I think I can actually make a quick substitution here that my radius is, or my base is actually 2 times my radius, because this is the same length as up here, which is the diameter of the circle, or twice the radius. So I'm going to actually take my base and substitute that in as 2r. So I really used a secondary equation right there in terms of my primary and secondary equation. Obviously I'm working with my area formula, but I just used the equation that my base is equal to 2 times my radius. And I'm substituting that in right here. Now that's not good enough, because I also need to do something with my height. So the question is, what can I do in terms of my height? And I don't know the relationship between that and my radius. There's no direct relationship. So I'm going to go ahead and try to use the fact that, and again, it's off my screen, but the outside perimeter is 60 feet. So the outside perimeter of this shape would be, all of that is 60 feet. So if I try to write a perimeter equation, I've got 3 sides of my rectangle, and then I've got part of the way, half the way around my circle. So the rectangle, I've got the base plus 2 times the height, and then half my circumference. Circumference, remember, is 2 pi r, so I'm going to divide that by 2, which is giving me, let's try that again, 2 pi r divided by 2, which is going to give me pi times my radius, because my 2's cancel. And again, this base we said was 2 times the radius. So I'm going to use that. I'm going to use that to make my equation. And perimeter, I was told, was 60. So I'm going to actually use this equation to now solve for the height, because I've got 2 variables, h and r, and I want to solve for h, so I can substitute something here in terms of radius. So I'm going to use this purple equation and solve 60 minus 2r minus pi times radius is equal to 2 times height. So I just move that term and that term over to the left-hand side, and I almost solve for h. I'm going to divide everything by 2. And I could have made one big fraction there, was one way to do it. I thought this might be easy enough to kind of go ahead and get, so I'm just going to go ahead and simplify right here. I've got 30. I've got the 2's cancel there, and pi r divided by 2, and those cancel. So I'm now going to substitute in for h. We'll see what this looks like. 30 minus r minus pi times r. That is my height. So I've got base times height so far, and then plus area of the circle is pi times radius squared divided by 2. So I'm doing a quick check, and you could have used a variable like x if that works better for you. You didn't have to call it r, I just used r for the radius, but it doesn't matter, whichever you're more comfortable with. And yeah, that's my area function. So that's checking out with what I had on my paper. So we're going to take it from there. That would be my good to go area equation, although I would say that, again, it's worth taking a minute to, let's go ahead and see if we can simplify that so that we can make our life easier when we take the derivative. So if I can, it's not going to let me, let's see if I can squeeze a little bit more on here. Let's see if I can simplify that. So I'm going to go ahead and distribute my 2r through my polynomial. 2r times 30 is going to give me 60r minus 2r squared. 2r times pi, negative pi r, is minus 2 pi r squared plus pi divided by 2 times radius squared. Notice how I wrote that as a coefficient times my variable squared. And I don't know if I can actually, I could potentially combine, if I wanted to, these two terms right here, because they're both pi something radius squared. So I could go ahead and put those both over 2, and that might be helpful. And then I've got an r squared term and an r without a pi, and I would have to keep those terms separately. But now it's a matter of 3 or 4 terms added together and add addition and subtraction between them. That's an easy derivative, folks. So just make sure you're paying attention to that. Pi is a constant, not a variable. So this is my new equation for area, and that would be the one that I'm looking to. Like I said, you could combine those last 2 terms, but otherwise I'd be looking to take the derivative right there, set it equal to 0, and you're going to get something kind of weird. There's going to be a pi in it, but it's really not bad. So see what you can make of that.